So hi guys, welcome to my channel. Today I'll be solving this GFG problem of the day, which is Kadanes algorithm. So again, marked as medium, accuracy is very less, but it's a very simple algorithm. And on the other hand, it's very important algorithm too. Now let's try to read the problem and try to see how we can approach it. Now one thing to be noticed is, or we can see that Kadanes algorithm is also known as maximum sum subarray. Okay, maximum, what it is? Maximum sum subarray. So first let me tell you about the difference between subarray and subsequence. Subarray means the continuous part you have to take, and subsequence means you can skip any element and you have to take out the sum. Okay, so subarray means taking out the sum of these continuous element, and subsequence means taking out the sum of any of the elements by skipping any of the elements, like -3 you have taken this, you have taken this, but in subarray you have to take the continuous part of the array. Okay, I think now the difference is clear. Now maximum sum subarray. Now what question trying to say is we have to calculate the maximum sum given by the continuous subarray. It might be this, it might be this, or it might be this, but we have to take the continuous part only. So I hope the question is clear. And to solve the problem of finding continuous subarray, like here it is given, find the contiguous subarray containing at least one number. The algorithm which is used to solve this problem is known as Kadanes algorithm. Now let's see how we can approach this. 1, 2, 3, -2 and 5. 1, 2, 1, 2, 3, -2, 3, -2 and 5. So as we can see that the contiguous subarray is this. So it is giving positive. So 3, 4, 5, 6. Its sum is 6. Okay. Now this is also 5. So its sum is this 5. We cannot skip, like we cannot skip 2 and take 6 plus 5, it is 11. No, we cannot do this because as just I have explained that in subarray we have to take the continuous part. Now 6 and it is 5. You will be saying that this is the negative number, so we will not be taking that, so we will be skipping that. So it says its maximum among 6 and 5 is 6, so we have to return 6. But no, the maximum subarray here is 11 -2, which is 9. Why? Because by taking this part we are getting 6, by taking only this part we are getting 5, but by taking the whole array we are getting 9. Why? Because 5, 6, 7, 8, 9, 10, 11 -2, which is 9. So 9 is our answer. 9 is our answer. So no matter if it is negative element present in the array, we have to see that the negative element is contributing to our answer and making the final sum positive or not. So let's see and make a dry run in this case, so we get a clear idea like how we are going to solve this Kadanes algorithm, and you will be like amazed to see that how it is working. So let's say I am initialized a sum variable. Sum is equals to int min, like minimum -2, 3, 4, 5, 6, 7, whatever, and one answer vector to store the maximum answer. Like my final answer will be storing it in answer vector. Now this person is standing here. This person is standing here. Okay. Okay, sum will be 0. My answer will be this. Sum will be 0. Okay. Now what is happening? My person is standing here. He has taken the sum of -2. Okay, we have included initially -2. Why? Because containing at least one element is mandatory. Now it has in the negative of -2. Now if we move to another index and he has a loan of -2, let's think it of as a money. Like he has a loan of -2, and whatever element he is taking from here, he will be contributing -2. Means if it would be x here and it would be like 10, let's forget about -3. If it would be 10 here, then he will be reducing this value to 8. So why I will be taking -2? I'll be doing this sum 0 and let's say here it is 10. So I'll be starting from here only and take the sum as 10. So what we'll be doing is, if the person has the negative value as the loan in his head, so he will be skipping that part, put the loan as 0, and then he will be starting fresh from here. So let's see. So he has -2 as this. So before moving to -3, he will be doing it as 0, and before that he will be updating as -2, because -2 is greater than -234 int min. Now my person is standing here. Okay, so again he'll be adding sum as -3. Now before moving to another index, let's say he has a loan of -3. While starting a new life, what he will be say that, okay, I am getting 4. So is it necessary to take -3 as my loan and starting the new business as 4? No, it is not necessary. It is not like beneficial. So what he will be doing is, because if we add 4 and -3, its some value will be reduced to like 1. So instead of this, he will break this part and start again a fresh new life from here. So what he'll be doing is, he will be do -3 to 0, and then he will be starting a new life from 4. Okay, so he'll be doing it as 0 and moving, starting again from 4. Okay, so now sum is 4. Now again, before moving to this index, he will be checking that, okay, I have the positive of 4. So if I move and start a new business, so 4 will be contributing to my business. Okay, so I'll be taking 4 toward with me. Before that, I'll be updating 4, because my answer is like storing the maximum sum till now. Now I'll reach here. Okay, previously I have 4, now I got -1, so I'll be having 3. Now I'll be updating answer. Is it maximum of answer comma whatever like currently I'm having sum? So it is 3. No, my maximum is still 4, so I'll be doing 4. Now before, okay, now before moving to -2, I'll be seeing that, okay, is it like whatever money I'm having, is it contributing to this? Yes, it is contributing to this. So I'll be taking 3 with me. So I'll be standing here, and 3 plus -2, which is 1. Now my current sum is 1. Okay, so again I'll be checking that, storing our answer as, by the way, answer is equals to, every time answer is equals to max of answer comma sum. So is it 1 is greater than 4? No, so I will not be updating our answer, because still I have this subarray which has the maximum 4, so I'll not be updating. Now I'll be moving to this index. Now before moving to this index, I'll be checking that whatever money I am having, is he contributing to this business? Yes, it is contributing. So I'll be taking this money. So what I'll be doing, 1 plus 1, it is 2, updating my sum as 2. Now again checking that, is 2 is greater than 4? No, because again this is the maximum subarray till I have. Okay, you can see that this is not the maximum subarray because it is giving 3. This is also not the subarray, it is giving 1. So I'm having the 4 as maximum subarray till now, and my answer is storing 4. So now 2 I have. Before moving to new business 5, I'll be seeing that the loan which I have, is it contributing to my new business? Yes, it is contributing. So I'll be adding this. Now I will be going here 2, and I'll be adding it as, so 7. 7 I'll be having. Now is 7 greater than answer 4? Yes, 7 is greater. So I'll be updating. Now you can see that magically we have taken 5 plus 4 9 plus 1 10 minus 2 8 minus 1 7. It is giving 7 maximum sum. By taking the -2 and -1 also, we have extracted the maximum sum among these subarrays. So our answer is 7. Now before moving to -3, we will be seeing that, okay, I have +7 in my business, so I'll be taking this at a as a like moving forward with 7. So I'll be moving forward. Okay, I'll be here, and plus 7 minus 3 is 4. Now sum becomes 4. Is 4 is greater than 7? No, 4 is not greater than 7. So I'll be not updating it. Now my person becomes out of bound. So finally, in my answer variable, I'll be having 7. Now we can check that. Is it minus 2 minus 3 4? Minus 2 minus 3 4, custom input. Minus 2 minus 3 4. Minus 1 minus 2 1. Minus 2 minus 1 1. Minus 2. Okay. Minus 1 minus 2 1. Space 5 space minus 3. Okay, so let's run this. It will be giving 7 as our maximum. 7, you can see that. Okay, so we got it. Now what is remaining? Okay, let's conclude it. So before, so let's say my pointer is standing at ith. Okay, now before moving to next index, we'll be seeing that if this person has the loan of negative, then it will be doing 0, because taking negative to next index is not beneficial. Instead, I'll be putting it as 0 and starting new from here. Okay, this is clear. And every time I'll be updating our answer, because I have to check that at what point of time my business is generating the maximum output. Okay, so let's see how code is working. So I have initialized answer as int min, temp as 0. Let's make it sum. Okay, every time I am doing is every time moving, I run a for loop. Every time moving a next index, I'll be adding it as sum, updating my answer, and then checking that whether I need to keep take this money to new index or not. So if this sum is giving me negative value, so I'll be doing sum is equal to 0 and again moving to this loop. So finally I'll be returning our answer. So let's continue. And one more thing, the time complexity of this algorithm is big of n. As mentioned, expected time complexity is big of n, and space is 1. We are using only variables, no data structures. So let's submit it. Okay, it got passed. So now this is how we are going to solve this problem. And again, the Kadanes algorithm is very famous algorithm to find the contiguous subarray. Now one thing to be noticed is, if we are given, if it is negative element in the array, then there is the point of calculating the maximum sum subarray. Okay, but what if there is no negative elements in the array? So there is no point of calculating Kadanes algorithm. Why? Because if it is given that 1 2 0 0 0 0 0 and 5, so we can clearly see that the maximum subarray is by taking the whole elements like 5 6 7 8. So if there is only positive elements in the array, then we can simply calculate the sum of all the elements in the array. So let's see by taking one more example. Like if it is given that 1 space 2 space 0 space 0 space 0 space 5, so it will be simply giving 8. So this is important point to cover, that I have covered, that if there is no negative element, then you will be taking the sum of all the elements. Okay, so thank you for watching and having patience.